guys, me again. No, I'm not wearing the same clothes every day. I just went ahead and shot multiple videos in one day. So, woohoo! Math all day long. All right, today you should be on page 94 of your workbook. We're still working with multiplication and division of fractions because now we're seeing that sometimes you could multiply or divide with your fractions and still get the same answer. It just depends on which way you put them because multiplication and division of fractions are related. So the first thing that it gives us for our warm-up on page 94, it gives us 2 times 1 and 8/9. And it wants us to give something that's a little too high, something that's about right, and something that's a little too low. And I know I have those on opposite sides, but that's fine. All right. Something that I think is too high. I think 50 would be too high. Something that's too low. Now, on this one, I know that I have 1 and 8/9 2 times. So I know there's no way that this could be a fraction, so I'm going to say that 1/9 is too low. And my about right, I'm just going to look at this and I'll say, okay, 1 and 8/9, that's just almost 2. So if I just look at it and estimate 2 times 2, then I get about 4. I think 4 is about right. So then I can actually go and do the math. I have 2, which I can write as 2 over 1 times, I can turn this into a improper fraction. 9 times 1 is 9, plus the 8 is 17, and then it's still in ninths. And then I multiply straight across. And if you're not sure, go to the side and do the math. 17 times 2. 2 times 7 is 14. Carry my 1. 2 times 1 is 2. Plus 1 is 3. So I have 34 ninths. Now, I also know that I can now take this big improper fraction and turn it back into a mixed number so that it's a number that's easier for me to work with and think about. So I would do it just like I divide and say it top to bottom. 34 divided by 9. 9 won't go into 3, so placeholder 0. 9 goes into 34 3 times. 3 times 9 is 27, and I subtract, and I get 7 left over. So 9 won't go into 7. I don't have anything else to bring down, so my remainder is 7. So I would have 3 whole ones and 7 left over, and we were dealing in ninths. So, was I about right? Yes, 3 and 7/9 is just about almost 4. So I was right in my estimate. Okay, on the next page. It gives you some word problems and it wants you to decide whether you would be multiplying or dividing, or you would be adding or subtracting your fractions to get the answer. And it's going to have you, in your workbook, it has you do it on 2 separate pages, but we're just going to go ahead and do the part 1 and part 2 all together, because part 1 just has you deciding if you would multiply, divide, add, or subtract, and then part 2 makes you actually work them out. So we're just going to go ahead and work them all out from the start. We're just going to knock it all out together. So on the first one, part A, it says 2/3 of the students in Lynn's 5th grade class have short hair. 1/4 of the girls wear glasses. What fraction of Lynn's class are people with short hair who wear glasses? So first of all, I think I'm going to multiply. So I'm just going to put an M over here, and then I'm going to see if that works out for me. I think if I read the problem, when I look at it, I say, okay, I know that 2/3 of the students have short hair, and 1/4 of those also wear glasses. And the key word to me is the of, because I know that 2/3 have short hair, and 1/4 of those have also wear glasses. Okay, so, and I know that multiply, does it matter what order I multiply in? Could I also say 1/4 of the 2/3 wear glasses? Yeah, same thing. So I know I'm multiplying, so I was right here. And then if I look at it as multiplication, 1/4 of the 2/3 that have short hair. 1 times 2 is 2. 4 times 3 is 12. So I can say 2/12 of the class, and that would be right. If I asked you to simplify it or write your answer in simplest form, both of these are divisible by 2. So 2 divided by 2 is 1. 12 divided by 2 is 6. So 1/6 of the students have short hair and wear glasses. Okay, on B. On B. B says a garden is the shape of a rectangle. That rectangle is 2 4/6 feet long and 2 feet wide. What is the area of the garden? Now, first of all, I think that I'm going to be multiplying, and I simply think that because it says area. Anytime we're finding area, we know that area is length times width. So, if I'm going to be finding area, I know I'm going to be multiplying. Okay, now it tells me that the length is 2 4/6 feet, and the width is 2 feet. So I know I'm going to be multiplying 2 4/6 times 2. So I can look at this two different ways. I can turn my mixed number into an improper fraction. I would have 6 times 2 is 12, plus 4 is 16. And then I can look at this as a fraction by placing it over 1. So I would have 2 over 1. And then I would multiply straight across. 16 times 2, if you're not sure, just go to the side and do the math. 2 times 6 is 12. Carry your 1. 2 times 1 is 2, plus the 1 you carried is 3. So you would have 32, and then 6 times 1 is 6. Okay, so if I was telling somebody that the area of the garden is 32/6, that doesn't make a lot of sense. So I know that I can turn it back into a mixed number that makes more sense when you're talking about area. So 32 divided by 6. 6 won't go into 3, so we placeholder 0. 6 goes into 32 5 times. 5 times 6 is 30. Then we subtract, and we have 2 left over. 6 won't go into 2. There's nothing to bring down, so we have a remainder of 2. So now I know that it is equal to 5 whole ones, and we had 2 left over, and we were dealing in sixths. So it makes more sense to tell somebody, okay, this garden is 5 2/6 feet. Now, if I had asked you to simplify it, because this is correct, but if I asked you to write it in simplest form, again, both of these are divisible by 2. So it wouldn't change our whole number. We still have 5 whole ones. 2 divided by 2 is 1. 6 divided by 2 is 3. So it makes a lot more sense to tell somebody that the area of the garden is 5 1/3. But your answer's not finished yet. It's 5 1/3 what? Okay, we were dealing in feet. And don't forget, if we're dealing in area, area is always squared. So your final answer would be 5 1/3 feet squared. Okay. On C says, let's see, there was ½ liter of water in Hans' water bottle, and he drank 1/3 liter of water. How many liters of water does he have left? Okay, so if we look at this one, again, I think I'm going to multiply because I'm thinking of it English to Mathlish. I think that he had a ½ liter and he drank 1/3. Okay? But if I look at it this way, that's my animals. Don't worry about it. They just knocked something off. Who knows? Okay? But if I look at it that way, now it doesn't matter which order I multiply in. That wouldn't change my answer. But I just want to look at it as, okay, he drank 1/3 of the ½ liter he had. 1/3 of the ½ liter that he had. And we know that of means multiply in math. So we have 1 times 1 is 1. 3 times 2 is 6. Now, this is telling me, got to be careful on this one. This is telling me that this is how much he drank, because we said how much did he have left in his bottle. So he drank 1/6 because he drank 1/3 of the 1/2. Okay, so now we got to think, okay, well then how much would be left? So if he drank 1/6, I'm not sure. So sometimes it helps to look at it as a diagram. Okay, if there's his bottle and here's half. He already drank, this was already gone. This was empty. Okay, so he only had half of his bottle to start with. And then says he drank 1/3 of that. So this is how much he drank. And then if we look at it, if this had all still been here, and this was just what he drank 1/6. Okay, so we got that part right. But it didn't ask that, did it? Got to be careful. The question asked, how many liters of water does he have left in the bottle? So this is what he has left in the bottle. And that amount would be 1/2. So, on this one, we did multiply, and that worked out for us. But then we also had to subtract, didn't we? We had to take out what he drank to see actually what he had left. All right. D. D says a pizza is cut into 8 slices. There is 3/4 of pizza left. If Noah eats another slice of the original whole pizza, what fraction of the pizza is left over? I have no idea. I have no idea if I'm going to multiply or divide or if I'm going to add, subtract. So I'm going to draw me a diagram. Here's my pizza. And it tells me that this pizza was divided into 8 slices. So we have 1, 2, 3, 4, 5, 6, 7, 8. And I know I'm no artist, so mine are never exactly equal, but we're saying that Miss Menard's a great artist and those are equal. So if I look at my pizza, it tells me first of all that 3/4 of the pizza is left. So if I'm just looking at my fourths, let me look at it just as fourths for a minute. Here it would be as fourths. So if 3/4 of the pizza, there's 1/4, 2/4, 3/4. 3/4 of that pizza are left. Now, so that would be 1, 2, 3, 4, 5, 6 eighths are left right now. But then it tells me that Noah goes back and he eats one more slice of the original pizza. So that would take out one more of our slices. So if we're looking at it, we would have each of the fourths has 2 slices in it, right? So if he ate one more of the slice, how much would it leave? It would only leave 1/8 left. Oh, back up. I just made a big mistake. I read the problem wrong. See, we all make mistakes. That's why we work in pencil. The diagram was right. I'm going to quickly draw that again. That was right. I have my 8. See if I can draw more even this time. Probably not. All right, we got our 8 slices. 3/4 were left, which was 6/8 slices. But then it says Noah went in and ate another slice. That's where I took another one off. So he went in and this slice was still there. All of this was still there. The 3/4 was there. But he went in and he ate another slice. So instead of coloring in another slice, I should have subtracted another slice. So he ate another slice. So now how many are left? There are 6/8 left. Now there's only 1, 2, 3, 4, 5 eighths left. Okay? So my bad. Sorry y'all had to erase, but we all make mistakes. As long as we learn from them, that's what's important. Okay, so we had to take our 6/8, but then we had to take out or subtract another 8. So this one, we were actually having to subtract fractions instead of multiply or divide. So they threw that one in there for you. In the teacher's guide, it tells you, it gives you a heads up that they're going to throw you in a couple to distract you. I didn't tell you all that up front, but now that I've shown you the distraction, now I can tell you what the teacher's guide said. All right. So that one we weren't multiplying or dividing. It threw one in there at us to see if we knew what to do. We were actually subtracting a fraction. All right, on E. E says you have half a bag of pretzels and you want to share them equally among 4 people. How much of the bag does each person get? Now, I think since I'm having to share something, anything I know I'm going to have to share, I know I'm dividing it up. So first of all, I'm going to say I'm dividing on E. And then I'm going to look at that and I'm going to say, okay, I have a half a bag of pretzels and I'm having to divide that up between 4 people. So I know when I'm dividing fractions, I need to look at my whole number of people like they're a fraction also by putting it over 1. And I would slide the first one over. We flip or get the reciprocal of the second, and then we multiply. So 1 times 1 is 1. 2 times 4 is 8. So each people would get an 1/8 of the bag. And that makes sense to me because I only had a half a bag to start with and I had to divide that half out by 4 people, so they're only going to get an 1/8. But if you weren't sure, just look at it in a diagram like we've done before. Okay, we only had a half a bag of pretzels to start with, so we only had this half. And then the half we had to divide it between 4 people. So if all of the bag had been there, all of the bag's not actually there, but if it had been there, each person would only get one of the 1, 2, 3, 4, 5, 6, 7, 8. So each person would get an 1/8 of the bag of pretzels. So were we right in dividing? Yes, we were. We divided our half bag of pretzels by 4 people. All right, next page, page 96. Okay, F. F tells me that Jada was planting a garden. She planted 3/8 of the garden in carrots and 2/8 of the gardens with squash. What fraction of the garden is planted with carrots or squash? Well, I'm not sure. I'm not sure if I'm multiplying or I'm adding. What am I doing here? Okay, I know that she had, let's see, 3/8 were carrots and 2/8 was squash. 3/8 was carrots and 2/8 was squash. And I know what and means in math. I have 3/8 carrots and 2/8 squash. So I'm adding. Because it says how much was planted in either carrots or squash. Well, 5/8 was either planted with carrots or squash. So this is another one they were throwing in there at you to see if you knew what math operations do. On this one, it actually wasn't multiplication or division. They threw the oddball in there. 3/8 carrots and 2/8 squash. So really watch for those English to mathlish words. We know and in math we are adding. Okay, on G. Elena bought 3 pineapples that each weighed about 1 2/3 pounds. How many pounds of pineapples did she buy? Well, let's see. I think I'm going to multiply. Okay, and let me think about that for a minute and figure out why I think she's going to multiply. First of all, I know that each one weighed 1 2/3 pounds. And she bought 3, So in my mind, I'm saying, okay, I had 1 2/3 3 times. All right, so in order to get started, I would have to multiply and add to turn my mixed number into an improper fraction. So 3 times 1 is 3, plus the 2 is 5. So I have 5 over 3 here, and we always look at our number as a fraction also by putting it over 1. And then I multiply straight across. 5 times 3 is 15. 3 times 1 is 3. Now, 15/3, it doesn't make a lot of sense to me to say, okay, she bought 15/3 pounds. But I do know that I can take this and read it top to bottom and do the math. 15 divided by 3. 3 won't go into 0, so we place 3 won't go into 1, so we place holder 0. 3 goes into 15 5 times. 5 times 3 is 15 with nothing left over. So how many pounds did she buy? She bought 5 pounds of pineapple. All right, let's see, we are on H. Okay, H says, a big water container can hold 4 gallons of water. If one bottle can hold 1/10 gallon, how many bottles are needed to fill the entire container? So first of all, I think I'm gonna divide. Okay, I know that if it's gonna take 4 whole gallons, and those whole gallons are going to be divided into tenths. Now, first of all, it makes sense to me that because it asks how many bottles am I going to need. Well, if each bottle is only 1/10, I know that my answer is going to be a higher whole number because it's going to take a lot of those bottles to get up to 4 gallons. So I know it's going to be a higher whole number. So if I use my rule for dividing fractions, I make this a fraction also by placing it over 1. And then I would slide over the first one, flip the second, or do the reciprocal, and then I multiply straight across. 4 times 10 is 40. 1 times 1 is 1. So 40 over 1 is equal to 40. Does it make sense that I would need 40 bottles? Yes, it does. It makes sense that I would need 40 bottles because each of those bottles was only 1/10. Now, you could also reverse think this one because it tells us at the beginning some of them can be multiplying or dividing. So let's think about this one. If we think of it in English to Mathlish terms, now I got 40, so if I had 40 bottles, if I had 1/10 ounces of bottles 40 times, I have 1/10 bottle, because that's how much each bottle will hold, 1/10 of, or 40 times, 1/10 40 times. If I place this, make it like a fraction, I slide over, and then I multiply, put this as a improper, I multiply, and I get 4. Now, does that make sense? I get 4. Yeah, that makes sense because how many gallons did I start with altogether? I started with 4 gallons. So if you worked backwards and multiplied, or if you just went ahead and divided, I'd give you full credit for either, because that is one of those that you could look at both ways. All right, the next one, I. The track at school is 2/3 of a mile long. If Diego runs 1/3 of the way around the track each day, what fraction of a mile does he run? Okay, well, again, I'm going to say multiply, because in my math brain, I'm thinking now, okay, he's running 1/3 of the track. 1/3 of the track each day. And it tells me that the track is 2/3 of a mile. So if he's running 1/3 of 2/3 miles, I know that I am multiplying. And then I multiply straight across. 1 times 2 is 2. 3 times 3 is 9. So he's running 2/9 of a mile each day. All right, and our last one, J. Claire plays her favorite song 6 times on repeat while she gets ready for school in the morning. If the song is 3 9/10 minutes long, how long does it usually take Claire to get ready in the morning? Well, I know, I think I'm going to multiply. And I think I'm going to multiply because I'm telling myself that if each song is 3 9/10 of a minute long, and she listens to it 6 times, I have 3 9/10 6 times. So I'm going to multiply. And I know that I first have to turn my mixed number into an improper fraction by multiplying diagonal and then add. So 10 times 3 is 30, plus 9 is 39, and we were dealing in tenths. I also know that I have to look at my whole number like a fraction by placing it over 1. So I have 39/10 times 6 over 1. So I multiply straight across. So I'm going to go to I can't do that in my head, so I'm just going to go to the side and do the math. 39 times 6. 6 times 9 is 54. 6 times 3 is 18. Plus 5 is 23. So I now have 234 over 10. All right. Now, it doesn't make a lot of sense for me to tell someone, well, it takes her 234 over 10 minutes to get ready for school every day. But I do know that I can turn this improper fraction back into a mixed number by dividing just like I would read it from top to bottom. So I would go over to the side and do the math. I have 234 divided by 10. Well, I know 10 won't go into 2, so I placeholder 0. 10 will go into 23. 10 goes into 23 2 times. 2 times 10 is 20, and then I subtract, and I get 3. On this one, I do have a number to bring down, so I bring down the 4. 10 goes into 34 3 times. 3 times 10 is 30, and I subtract. 10 won't go into 4. There's nothing else to bring down. So I have a remainder of 4. So how many whole minutes does it take her to get ready? 23 whole minutes and 4/10 of another minute. Now, I would take this for full credit if I asked you to simplify or write it in simplest form. Each of these are divisible by 2, so we would still have 23 whole minutes. 4 divided by 2 is 2. 10 divided by 2 is 5. So she takes 23 2/5 minutes to get ready in the morning. All right, and if you were just doing an estimate, just to see, make sure your answer is reasonable in your head. 3 9/10, that's almost 4, isn't it? And 4 times 6 would be 24 minutes. So is my answer reasonable? Yeah, my answer is reasonable. It is correct. All right, so that's going to wrap us up for today, because part 2 on the next page, it was just having you work out the problems after you decided if you were going to multiply or divide. We just did that all at one time instead of going back and forth. So you guys make sure you've got all this in your workbook so you can look back at it. And I'll see you guys, actually I'll see you in a few minutes, because I'm going to go ahead and do the next video in a few minutes, but you'll be seeing it tomorrow. So